Hello everyone, welcome to the second video lecture on circuit analysis one. So in the last session we have seen basically the examples on charge and current, how we can determine the current when the charge is given. So today we will see if the current is given, the expression for current is given, so how can we determine the charge which is flowing through the element. So let's consider the first one. Let's consider the first one, which is I of t, okay, I of t, which is 3 ampere, and Q of 0, which is equals to 1 coulomb. So basically, when we are saying Q of 0, it is the value of the charge at t is equals to 0. Q of 0 means at t is equals to 0, we have the initial charge on the element, which is 1 coulomb. So we have said that the expression for charge is given by the integral t, which is t naught up to t I of t by dt. Okay, so the limit of integration starts from 0, so we'll have the integral 0 up to t, the current which is given by 3 dt. Okay, 3 dt. So for this integration, you can have the value which is 3t, sorry. Okay. So that is 3t plus a certain integration constant, So to determine the constant, let's consider at t is equals to 0. At t is equals to 0, Q of 0 is 1. Okay, so let's substitute this. That means 1, which is equals to 3 into 0 plus a. Okay, plus a. So 1, which is equals to 0 plus a. So you have a is equals to 1. Okay, so Q of t, which is equals to 3t plus 1 plus 1. So this is the expression for the charge which is flowing through the element. Now let's consider at t the second equation, which is I of t is given by 2t plus 5 milliampere, and the initial charge value at t is equals to 0 is 0. Okay, now let's consider Q of t, which is equals to the integral 0 up to t 2t plus 5, okay, plus 5 by dt. Okay, so you have 2t square over 2 plus 5t plus 5t, so which is evaluated from 0 up to t. Okay, so you have this will be cancelled, t squared plus 5t, of course, plus certain constant integration plus a. So at t is equals to determine the constant, let's consider at t is equals to 0. At t is equals to 0, Q of 0, which is equals to 0. So 0, which is equals to 0 square plus 5 times 0 plus a. So from this, a is equal to 0. So Q of t, which is equals to t squared plus 5t millicoulomb. So this is the expression for this current passing through the element. The expression for the charge is given by this expression. Okay. So please try the other questions by yourself, so that it will be clear for you. So we come to the third parameter, which is voltage or potential difference. This is the voltage or potential. It is the energy required to move a unit charge through an element. It is also called electromotive force. This is electromotive force. Motive force, another name for voltage or potential difference, and it is measured in volts. So the unit of voltage, it is volt. So voltage drop is the difference in voltage between two ends of a conductor through which current is flowing. Okay. So the definition VAB, which is a terminal A and B for this circuit, is given by d by dq of the energy, d by dq of the energy supplied by the source. Okay. So where W is the energy in joules and Q is charge in coulomb. So 1 volt means that is 1 joule per coulomb, which is 1 joule, you know that 1 Newton meter. So that is 1 volt means 1 Newton meter per coulomb. Okay. So that's the potential difference or voltage or electromotive force. So what's the instrument? The instrument used to measure voltage is voltmeter. Instrument, that is voltmeter. It is voltmeter. Okay. The instrument which is used to measure voltage is voltmeter, and connection scheme for voltmeter is in parallel. That means, so the voltmeter, it has high resistance value. Okay, high resistance value. To mean that the current passing through the voltmeter is 0. That means there will not be voltage drop on the voltmeter because there is no current pass through the voltmeter. Okay, so you can see this plus minus. So this is the load. So we need to connect in parallel with the load to measure the voltage across the load. So this is voltmeter, and this one is load, and this is voltmeter. This is the source, Vs. Okay, Vs. So we have two types of voltage as that of current. That means the DC voltage and the AC voltage. So you can consider here the AC voltage. This one is AC voltage. This is AC voltage or alternating current voltage, and this one is direct current voltage. Okay. So for this case, as you can see, goes on, the voltage will be constant. At 240 volt. Whereas for this case, the voltage is varying. The voltage magnitude as well as the direction is varying. So for the first half cycle, the voltage starts from 0 and it increases to the positive direction and attains its maximum value, its peak value. Then after attaining the maximum value, it will drops down and goes to zero value. After crossing the 0 value, it will increase in the negative direction to its negative peak value. After achieving its negative peak value, it will goes to the 0 value. zero value. So you can see this is for one full cycle of sinusoidal voltage, sinusoidal alternating current voltage. Okay. So when it comes to the electric power, it is the rate at which electric energy is transferred by an electric circuit. So the SI unit power, the SI unit of power is watt, or power, it is the time rate of energy. That means the time derivative of energy with respect to time, Okay, so watt means 1 watt means 1 joule per second. So the electric power is usually produced by electric generators, but can be also supplied by using electric batteries. Okay. So we can consider the electric power. P is the time rate of expending or absorbing energy. That means when power is absorbed by the elements of the circuit, basically it is positive. When power is supplied by the source, the power is negative. So definitely the definition of the power will be given by this expression. That means P is given by P of t, which is given by dw by dt, where this is energy. Okay, so let's multiply both sides by dq by dq. Okay, p of t, which is equals to dw by dt times dq by dq. So you have dw by dq times dq by dt. Okay, so this expression is voltage, and this one is current. So from this, P, which is given by voltage times current, So P is the electric power in watts, and W is the energy consumption in joules, and T is the time in seconds. So another expression for power is given by this P, which is equals to V times current. Okay, V times current. So we may calculate the power at terminal of a resistor in several ways. So the first method is we use a defining equation as follows. So you can see for the first method, we use the defining equation as follows. The defining equation, which is you can see power, which is given by V times current. So for this is the passive sign convention. This is all about for this session. So please share, subscribe, like my video lecture, so that it will be accessible for the others. Thank you.